Algorithms and data structures. So we've talked about algorithms in a previous nugget, and we saw that it was really just a way for us to solve problems. And so I'm going to give you some real-world examples in this specific nugget. We'll take a look at algorithm implementation, and then we're going to take a good look here at the basic building blocks of storing data and programming. And we're talking about data structures. And we've looked at things like variables in a previous nugget, which is just a way to store a piece of data. Now, most applications you're going to be storing and working with a lot of data. And we saw one way to do that in a previous nugget was with arrays. And an array is a way to store a specific type of data and a lot of it. Well, we're going to take this a step further in this nugget and look at not only things like arrays. We'll kind of rehash over what arrays are just to refamiliarize ourselves with them. But we'll also take a look at array lists. We'll look at linked lists. We'll look at stacks, queues, and just all the different ways that we can store a lot of data, a group of data, and how we can work with that data, and just some different usages and scenarios with them. All right, so let's jump into the outline here, take a little more of a look at what we're going to cover. We'll start with just an overview of algorithms and data structures, and here I just want to get you familiar again with what an algorithm is. Some of the algorithms we'll be looking at here, such as the bubble sort algorithm and the quick sort algorithm, a couple of sorting algorithms we'll get the hang of. Some common things you do in programming, obviously, here is sort data when you have a bunch of it, so we'll look at how to do it. And then we'll just get some examples going of data structures and what they are and how they look in memory, because half of knowing what these data structures are is to understand the internals of them and how they're stored in memory. The other half is knowing how to use them in code. So we'll kind of cover both halves here. In the first half, we'll just get an understanding of what they are and how they look in the computer's memory. Then we'll take a look here at data structures. I'll show you here what an array looks like, how we can work with it in code. Here we'll jump over to Nugget Lab and get familiar with arrays or array lists. We'll look at stacks, queues, and linked lists, and then after that we'll get into some sorting algorithms here. I'll show you what a bubble sort's all about and how the quick sort is built in to a lot of the collections in .NET. And collections is just a fancy word for a bunch of data, a grouping of data stored inside of a single variable. Because all of these things are really collections. It's just, when you say the word collection, it's just kind of a generic term to describe all the different ways that you can store data. But the specifics there would say, if I were to say array list, or if I were to say a stack or a queue, those are the specific implementations of a collection. All right, so let's jump into algorithms here and data structures and just get an overview of what we're going to be working with. And let's start here with an array. So an array is just a contiguous block of memory. That's how it's stored in memory. And think of it as just a collection of variables. Even though it's just one variable, really it's a bunch of variables stored inside of one variable. So if we were to create an integer array, for instance, right, we would declare it in C# something like this: int I, and you know what? I forgot the important part here. When you're declaring an array, you need to specify what size. So we could do something like this, right? 3. That's a 3, by the way. Sorry about my handwriting; it's pretty awful. And but that gives us 4 elements, because again, everything is 0 based. So 0, 1, 2, 3 is 4 elements. This would give us an I variable with 4 elements, just like this right here. This is what it would look like in memory mapped out. And then we could start assigning values to each element in here. So we could do something like this here. We could do an I open bracket 0 close bracket equals 1. A little semicolon there for the terminator. So we're referencing the 0 based index, which is actually the first index in the array. And we're storing 1 in it. All right, so it would look like this then: 0, 1, 2, 3. These are how we would reference them. And then if we were to change this to a 1, maybe this to a 10, we'd be storing a 10 here, and then so on and so forth. So that's an array. And some of the common operations you'll do on an array is just simply create it, initialize it, store values in it, maybe sort it. In fact, when we get into our demo, I'll show you how we can apply a bubble sort, the bubble sort algorithm here, to an array. So we can sort the array here. Other than that, arrays are pretty much everywhere, but they're getting kind of old, because there's a lot of things that we can do with some of the newer stuff, such as an array list, for instance. An array list is a lot easier to work with. One of the main limitations to the array is that it is not dynamic. In other words, say that we created this array here, this integer array, where we have 4 elements in it, and we wanted to add a 5th element. Well, guess what? That's not an easy thing to do, because an array is fixed. So it's not dynamic. We couldn't just add an element to this easily. We'd have to copy the array into a new array and do some funky things that would bloat our code. So that's why the array list is around, because it's there for dynamic array sizes. We can just do an array list.add, throw in a new item, and it'll add it, and it'll do all that stuff under the hood for us. So that's one of the nice things about some of the newer stuff, is it makes it very easy to work with. And I'll give you a good example here. When we get into our demo, I'll show you how to work with both an array and an array list. Now we also have the stack, and the stack is one of those kind of special purpose items that, if you have an application where you need to process things last in, first out, it's a good data structure to use. And what does that mean, last in, first out? Well, that basically means that as I put things into the data structure, if I were to put anything else on top of it, think of it just like it's getting piled on top of it. And the only way to get it out is to take everything out above it first. So just like this, last in, first out. So if we filled this stack up with 4 items, 1, 2, 3, 4, how to get them out is we have to take 4 out first, and then 3, and then 2, and then 1. So the last one in is the first one out. And how we do this is we have these operations here called pop, push, and peek. These are the 3 big ones here that you're going to work with when working with the stack. And push puts them onto the stack. So in this case, if we were to have a 1 here, if this was empty and we called push, it would push 1 to the bottom of the stack, or the top of the stack, depending how you look at it. It's the first one, right? Is it the top or the bottom? Well, if you were to put anything else on, if you were to push something else on, like the 2, it would go on top of the 1. And then depending on when you call pop, it would pop it off of the stack and give you a reference to that object. Peek actually takes a look at the item that's on top, that's next on the stack, without removing it, because pop, if you call pop, it's going to take it right off the stack and give you that object to work with. And again, we'll get some good examples going on how to work with the stack here in our demo as well. And we also have a queue, and the queue, think of it as kind of the opposite. Where the stack, we take things off the top when they come out, when we pop them off. The queue, we're going to take them off the bottom. So if we filled this up here with 1, 2, 3, 4, and by the way, you're going to use, instead of push and pop, you're going to use NQ and DQ. And peek is still in there, by the way. You still have peek here with Q, but it's just called NQ and DQ. So Q, you add them into the queue. DQ, you take them off the bottom, right? So they actually come out of the bottom like so. Now we also have a linked list, and a linked list is a lot like an array and a lot like an array list. In fact, an array list and even a list, I'll show you some of these objects when we get into .NET, are both built on top of an array. They just make it a lot easier to work with an array. So really, you can compare linked list to an array list, or a linked list to an array, because they're very similar in nature. The difference is, again, an array is just a contiguous block of memory, one big, honking block of memory, where a linked list is a collection of nodes that all contain references to one another, right? So it would look like this. And the big difference here comes down to not only how they're stored in memory, but performance. Because if you're working with a lot of data, a linked list may be better on performance because it's better in memory than an array, because an array is, again, one big honking piece of data. So, and the other thing here, though, is linked lists can be difficult, a little more difficult to work with if you need to do things like random access. If you needed to pull out a specific element in the list, arrays are more suited for that, where linked lists are, you're going to have to search the whole tree, all the nodes, link by link to find it. You're going to have to traverse the chain to find out where it is, because there's no real random access associated with linked lists. But linked lists are good for sequential access. And again, they're slightly faster depending on what you're doing. So, and there are some other differences between the minor differences, but the big thing to take away from linked lists here is that use them when you're using a lot of data, and performance is going to be an issue, or memory, if memory is an issue as well. So yeah, the internal structure, though, just think of a linked list as a chain. One link of the chain holds the data, the other link holds the connection to the next piece of data. All right, so that's pretty much all there is to linked lists here. Now, algorithms, just to get you familiar with a couple of real-life algorithms here. Some sorting. Sorting is a big popular thing to do in the programming world, and thankfully we're kind of getting spoiled these days with .NET 4, because a lot of this stuff is done for us. In fact, I'll show you, the quicksort algorithm is built in to pretty much all of these things, or at least most of them here. Well, the stack and the queue you can't really sort, because you can't mess with their positions or rearrange them or anything. You can reverse them, but you can't really reposition anything in there outside of creating a new one and putting it in the order that you want. But when it comes to arrays, lists, array lists, regular lists, linked lists, all those other sort of common data structures that you'll be working with. Sorting is a big thing, a very popular thing. And again, it's built in here with .NET 4, at least the quick sort, but the bubble sort isn't. So I'm going to show you how you can write your own bubble sort routines here using the bubble sort algorithm in .NET. But essentially how the bubble sort works is it's kind of a double loop. We're going to create a double loop. We're going to create a loop that takes each item and compares it to each other item in the list. And then how it works is, if we have something like this here, if we have, say we have 6, 9, 1, 12, we would start with 6, and it would go and compare this to 9. Is 6 greater than 9? It's not. So 6 would stay there and 9 would stay there. Then it would compare 6 to 1. Is 6 greater than 1? It is. So what it would do is it would reverse the 1 and the 6. Is 6 greater than 12? It's not. So 12 would stay there, 6 would stay there. And then it would go to 9. And it would just keep doing this, compare everyone to everyone, until all the large numbers sink to the bottom and all the small numbers bubbled up to the top. So I'll give you a real life demo of how the bubble sort works. And it was really not a lot of code to write a bubble sort routine. And it's better to see it in action because we can kind of walk through the code and watch it fill up this data and swap them around and come up with a sort that works. So the big thing with the bubble sort though is that it's very slow. It's actually known as one of the slowest sorting algorithms out there. And if you think about it, doesn't it seem kind of inefficient comparing every value to every value? There's got to be a better way to do it, right? And there is. And that's where the quicksort algorithm comes in. And Microsoft actually chose the quicksort algorithm as the sort method behind all of their lists because it is quick and it's known as one of the quickest ones out there. And how it works is it kind of uses the divide and conquer that we learned about back in the recursion nuggets that we looked at here. And basically what it does is it partitions your block of data over and over again and sorts the partitions to come up with the lowest, to come up with the actual sort values. So how this works here is if we had a block of data, 51342, and we wanted to sort it, how it would happen underneath the hood is it would first pick a seed. And let's say that it picked 3 as our seed. What it would do is it would push everything that was less than 3 over to one partition, everything that was greater than 3 over to another partition, and then it would do it again. It would then pick another seed and repartition it on each side. And what this does for, underneath is it creates all of these little blocks of memory here. And it's a lot easier to work with small blocks of memory than it is to work with big blocks of memory, a lot more efficient. So that's why it's so fast. It just keeps breaking this down using divide and conquer and sorting it in these small blocks over and over until it's done. So thankfully we don't have to write any sort of routines that use quicksort because it's already built into a lot of the objects in .NET. If you did though, it wouldn't be hard to look up the sorting algorithm and then write your own routine. And again, I'll show you how we can do that with the bubble sort. Alright, what do you see? We head over to Nugget Lab and take a look at how we can work with algorithms and data structures in C#. Let's minimize the whiteboard, head on over to Nugget Lab. And once we're over here, I'm just going to head down to the Start button, fire up Visual C# 2010 Express. And I've got a solution in here, 12-algorithms and data structures. So the first thing I want to get you familiar with here is just some arrays. And I've got a console project here with a program.cs here. And I just want to kind of rehash over how we can work with arrays, initialize them, work with storing data in them, and then taking data out of them. So one way we can initialize them is like so here. Data type followed by the brackets that denotes that it's an array, followed by the name of the variable, and then we instantiate it equal to a new integer data type with 4 elements. Alright, so that's going to give us 0, 1, 2, and 3. So now we can just simply assign values to every one of the elements in the array using the index, like we're doing here, 5, 10, 15, and 20. From there, if we want to access an array, we can just simply loop over the collection using a for each loop. So we're saying for each integer data type, we have our placeholder here called num that we're going to reference inside of our loop, inside of the nums array. So it's going to loop through every single one of those elements, and we're just going to output to the console window the value. And then we'll do a console.read so it'll stay open and we can see it. Alright, so I'm just going to copy our numbers array function here and type it in up here. And if we hit run, we should get that 5, 10, 15, 20, just loop through it. And that's really how you can initialize, store data in them, and then get data out of the array. Also, as an alternate syntax here, you can initialize and set the values all in one shot to save on some code. So this here is the equivalent of one line of code above it here, where we just, it's the same declaration except that we add some curly braces along with the values inside of it. That'll initialize the array to have 4 elements in it. So again, the only problem with arrays here is we cannot, if we tried to do, something like this, right? This is going to fail, obviously, because we can't just add something to an array. An array is the memory's already been allocated. It's kind of a static thing at this point. So if we run this, we should get index was outside of the bounds of the array. A popular error you'll probably see many times in your programming days. So that's arrays. Very simple version of arrays. Another thing here I want to show you is array lists. And an array list is built on top of an array. It just has a lot of cool stuff done for us. Things like dynamic arrays, which is exactly what I'm doing here. Is we just create an array list, calling it strings, equals a new array list, and now you can just start adding things to it. And the nice thing about array lists is you don't have to stick with a data type. You notice we didn't really create an array of an integer data type. We just created an array list. So we can store whatever we want inside of this array list. Now keep in mind, if you store many different types of data and variables in here, you're going to have to do type checks, obviously, right? Otherwise you'll get type checking errors. But for simple things, it's very easy to do. You just call the name of the variable .add, pass in what you're adding in. In this case, we're just going to add a bunch of strings into the list, and then the same thing, we're going to loop through it using our for each loop here, and our str is our placeholder inside of our strings variable, and output it to the console window. So let's do the same thing. I'm just going to copy this, paste it up here. Let's try that again here. Copy, paste, there we go. And if we hit play, there it is. This is a dynamic array list. And we could add things on the fly here. Strings.add. And let's just add a 1 in there. Alright. Now this is also going to blow up on me because we're not doing any type checking down here. But, just to prove the point here, if we hit run, there we go. It made it through most of them. It made it all the way to the array list, and then it blew up on us here and says unable to cast the string here to an integer data type. Alright, so we'd have to put some kind of cast in there. But another thing I want to show you about array lists is it makes it very easy to do a lot of things, from doing things like reversing the list, to removing items out of the list, to sorting, which we'll cover here in a little bit. That's our quick sort there going on, and and a host of other things that this supports. So very easy to use the array list. I suggest using it whenever you can. The performance may be just a little bit below that of an array because it's built on top of an array, but it's a much more versatile object than the array because it supports dynamic things. So if you need dynamic sizes, definitely use the array list. You may not have a choice. Otherwise, if you need the performance and you've got a set number of items you're working with, then stick with the array. And one thing I do also want to mention that's very important is if you want to work with a lot of these objects, they're inside of the system.collections namespace. Remember I was mentioning collections are kind of a generic term? Well, that's why the namespace is called system.collections, because it's just a generic way to describe all the classes inside of it that support working with lots of data. Alright, let's scroll down and look at a linked list. So a linked list, again, is a good choice for when you're working with a lot of items. You need a lot of storage, you need the performance, and especially if you're working with things that require sequential access, because you can't really go searching for a specific item and do what we call random access. And random access would be, if you look up at our array here, something like this, followed by the index, referencing it by the index. You can't do that. That's considered random access because we're just kind of grabbing it at will, whatever we want, out of the list. Well, linked list, again, here we cannot do that. You'd have to write a loop and then do checking on each item in the loop. But this may be new syntax for you here. Right here, this is considered here a generic, and basically what that is we're defining a linked list with a specific type. So we're saying in this linked list that we're defining, only strings can go into it. All right, so that's really all that is. So we're creating a linked list. We're calling it linked strings, setting it equal to a new linked list of a string type, and then we're just filling it up. And I'm doing a couple of things here. The first two that we're creating is we're creating actual nodes out of. So we're doing a linked list node, getting a reference to it, and then calling linked strings.add last. So this will add the string 4 to the end of the chain. All right, so this will be at the very end of the chain, and then the next line of code we're adding 1, the string 1, as the first node in the chain, so the first node in the linked list. So we set up our first node and our last node, and then after that we can just, since we have references to these objects, we can call the add before on it, pass in what we want to add before, 3, pass in what we want to add after the first one, 2, and that should give us 1, 2, 3, and 4 through our loop here. All right, so let's try this. Let's go up top. Let's just call this linked list and hit run, and there we go. 1, 2, 3, 4. All right, let's head over and talk about stacks and queues. We're going to come back to our console application here when we talk about sorting, so we'll definitely be back. But let's close out of it for now, minimize our project, and head on down to our Win4 project, where we're going to set this as a startup project. And in here we have a main form here. I just want to show you how you can programmatically work with stacks and queues. So I tried to make this a little bit different, just to give you some variation here as far as the demos go. So what I did is I made an order object, very simple order object. Inside of here we have just an order class with an order ID, a name of the product, quantity, priority, and the order date. All right? And I also made an enumeration here called order priority, so we could track normal or high priority. So what I did back in our main form then is we've just got a little place here to track the product, the quantity, and the priority, and you can either add it to the stack or add it to the queue. So if you add a bunch to the stack, you add a bunch to the queue, what'll happen is I've got this timer down here which runs based on the interval here, every 10 or 20 or 30, whatever you define, seconds. So whenever this timer kicks off, so what it does, it's going to process the stack and process the queue to kind of just show you the difference between the two, and so you can kind of get a hang of what it looks like and how you can work with, you know, pushing and popping things off the stack, on and off the stack, and queuing and dequeuing things out of the queue. So let me give you a quick demo of how this application works before we jump into the details here. I'm going to hit run, and let's just add a product here. Let's add a TV with a quantity of 1, add it to the stack. Let's add, how about a watch here, or watches we'll call it, because we'll put a quantity of 2, add it to the stack, and then we'll add some jewelry, make this a quantity of 3 and a priority of high, and add that to the stack. And there we go. We've got 3 items on the stack right now. It should process shortly. There we go. And you can see last in, first out. Because what happens here is the way we have our loop set up is it's going to add this to the string, then it's going to add this to the string, then this to the string. So it was processed from top down. So jewelry actually got processed first, followed by watches, followed by the TV, which we entered first, but it was the last one to get processed. So that's how stacks work. Now let's do the same thing on the queue here. Let's just add a TV with 1. We'll leave that at high here, add that to the queue. How about a watch? 2, we'll put this to normal, and we'll add that to the queue, and then jewelry here. 3, normal, add that to the queue. So we've got 2 things in the queue here, and I spelled jewelry wrong, sorry about that. I got it right the first time. And then there it is. So this time it's the reverse, because it's the way you enter it in which it comes out. So the way it went into the queue is the way it's going to come out to the queue. TV we entered first, that's coming out first, followed by watch, and then our misspelled jewelry. And you know, another good way to think of the queue is think of the printer queue. If you've ever worked with a printer before, and you send a print job over to the printer queues it up locally on your machine, and then it also has a print queue, you know, on the machine itself in case there's many people sending it, and it processes in the order that receives them. So that's what a queue is very useful for. Is if you know you have some sort of job system, or you know you have things that take a long time to process, you're not going to process them all at once. You're going to queue them up. So you know, unless there's a priority on them, and that's where a stack can become useful. Is if you have priorities on them, then you can do peaking and you know process the higher priority ones first. And I'll show you how we can do that. But let's just head into the code here. Give you a little peek at the code behind. We'll open it up. Oh, wrong one. We want to open up our main form code behind here. We already looked at our order class that we created. So let's go into the code behind for the main form. And here at the module level here, I've got 2 objects. We've got a queue object here, and then we've got a stack object. Both of them are tied to the order data type that we created, which means you can only add orders into this specific type of queue. Again, this is these are considered generics. And you know, if you've never heard of the term generic before, don't worry, you will in the future when you get familiar with this stuff. But just basically it means this queue is kind of a generic object because it can accept, we can kind of transform it into any kind of data. It can store any type of type that we specify when we declare it. So think of it like that. But here we go. We've got them set up. They look pretty much the exact same setting up, and working with them is very similar as well. It's just the implementation is just a little bit different because they just function a little bit differently. And of course, like I mentioned here, we've got pop and push, we've got NQ and DQ. So we've got our module level variables set up so we can work with our queue and our stack. In our form load event, I'm just setting the data source equal to the enumeration. See this enumeration right here? Here's a trick that you can set a data source calling the global enum keyword here .get names, and then pass in the type. And the type of this is the order priority. And this is a really cool thing, and you'll certainly do this in the future if you need to do any sort of lists, drop downs based on enumerations. Really handy to do this one line of code, because look at that. You can now you can tie enumerations into drop down boxes, list choices, all that kind of stuff very easily with one line of code. So the next thing we have here is our two buttons, our add stack and our add queue buttons, and this is where push and NQ come into play. And what I did is I created just a very simple and generic routine here called create order from UI. So this is going to create an order object. It's going to fill it up with all the data from the UI. And by the way, I made the order ID a GUID, or GUID as people call it, a globally unique identifier. And this is just it's always going to give you a unique 36 character hexadecimal kind of string looking thing. And I'll show you what it looks like here in a second. But a lot of people, when they work with databases, use auto numbering to uniquely identify rows. Well, that can get hairy sometimes and messy, especially if you have a lot of data. All right, so a lot of people use GUIDs because they're guaranteed to be unique, and you know, they're easy to work with as well. A lot easier to work with than auto numbering, because you have to deal with the seeds and all that, and if things go wrong with the seeds, things can happen. So that's why I did that, just to kind of start getting you familiar with some of these things. And then we just set the product of the order equal to the text of the text box right here. All right, and then same here with quantity. We just convert it to an integer, whatever's in the text of the text box. The quantity text box right here. And then we have to reverse out of the combo box using an enum.parse, passing in the type of, which is the order priority enumeration, and then the selected value of the combo box. We turn that all into an order priority and store it as the priority of the order. And then we just set the order date equal to datetime.now, and we return this as an order object. So that's all we're doing here with our push. Is in the add stack, we're saying order stack.push onto the stack the result of this generic kind of routine that we just made that'll return us an order. And the next line of code here, this just updates the group box here, right here. So we'll have our count refreshed. And then with our queue, we do the same thing. We just NQ it rather than push it onto the stack. But everything else pretty much works the exact same here. So if we want to see what this looks like, I'm just going to set a breakpoint right here, and our add queue button. And just to show you what well, actually we'll see it here. We'll see it when we look at our watch window in our debug mode here. So I'm just going to set a breakpoint there. I'm going to hit run, and let's just add our TV back in here. We'll add one to the stack. We'll add one to the queue, and this will break it for us. There we go. Now if we expand this, which means this form, see this right here? We've got our order queue and our order stack. Here's our queue with one item in it, and it's our TV. And here's what a GUID looks like, by the way. See that? There's our unique identifier. And then same here down here with our order stack, same exact thing, but of course we're going to have a different GUID here because every time you generate it, it's going to be unique and different, right? So everything else looks the same. We got our priority, we've got our product, we've got our quantity, we've got our date and time, and that's how it goes. So that's really just how we can push things onto the stack and enqueue things into the queue. Now, the next really interesting part here is once we've added a bunch of things to the stack, added a bunch of things to the queue, what about working with these items? What about when it comes time to take them off of the stack, what we call popping off the stack, or dequeuing, taking them out of the queue? Well, that's why we have this in our timer right here. You can see here's our timer in the tick event. So every 20 seconds, which is what we have set at the default there, it's going to call process order stack and process the order queue. So here's our stack, and then here's our queue. Well, actually, you know what? This is our complicated stack. I'm going to show you this next because it's got the peek into it. But here's our process order queue below that. So let's take a look at the stack first. And what you do is we can just create a loop to go through the entire stack. That's what we're doing. So while the order stack.count is greater than 0, because every time we call pop, it's going to actually remove and give us that item. So it's going to give us that object off the stack and then remove it from the stack. So pop does both of those things, returns it to you and removes it. So, and then, what you do at that point is up to you, whatever you want to do. In this case, we'll get our order object back out of the stack, and we can work with it. And we're just simply going to, create a string builder object here and append a line to it that says, the order, the product name, is going in the 0 placeholder here, followed by the quantity is going in the number 1 placeholder here. Order has processed, and that just throws it into the string builder. It'll keep looping until everything's done. It'll create this big string with all the items and their processing statuses in there, and that's when we just add it into the text box here. All right, so that's really all there is to working with it is pushing things onto the stack, and then when you need them, you pop them off of the stack. And really it's the same thing with the queue. If we scroll down to our queue, everything is virtually the same except we call it dequeue. We take it out of the queue using dequeue rather than popping it off of the stack. All right, so that's how that stuff works. If you want to take a look at a more complicated scenario here, let's take a look at how we can work with peaking. And in fact, let me just go up here and let's just do a with peak here. There we go. So now when the processor takes over, the timer's tick event happens, it's going to call this method rather than the other one. And what we're doing here is we're peaking at the next item in the stack. And we're saying if this item has a high priority, process it first. So we're really just kind of doing a swapping thing, where we're creating a cur order, is going to pop it off of the stack. That's the current order that we work with. And we're going to create a placeholder here for our next order. And then what we're doing is we're saying if the order stack count is greater than 0, because once you call pop, if it's the last item and you try to peek at the next item, it doesn't exist, you're going to get an error. So we need to make sure that that we're not working with the very last item in the stack here. So if we're not doing that and we peek at the next item and the priority of the next item using peek here equals high, then what we're going to do is we're going to switch them around. We're going to set the next order equal to the current order, and the current order then we're going to pop off the stack. So the one we're peeking at, we're going to pop off the stack, and then what we're going to do is we're going to down here push back onto the stack the order that we were originally working with. So basically what we're doing is if it's a high priority item, we're reversing it and putting that on top of the stacks as the current item to work with, and then putting the current item that we did have back onto the stack so it'll hit the next loop. And that's really all there is to it. So if I hit run here, and let's just see if this works, we'll type in TV. This is going to be our normal priority. We'll add that to the stack. How about watch here with a normal priority, add that to the stack, and let's add some jewelry again here. 3, this would be a high priority, and we'll add that to the stack. Now what should happen is this right here. See that? Jewelry was processed first because it was in the middle, and because of that, it got switched around. It got flipped. It traded places with the watch and became the high priority, and that was the one that was processed first. So, and I do want to mention that you can do that with the queue as well. You can do peeking at the queue, and peeking does not remove it from the queue like pop does. Pop or dequeue actually removes it as soon as you call it from the queue. Peeking just lets you look at it without removing it, and then if you wanted to remove it, you'd have to do what we did here and pop it off or dequeue it from the queue. All right, so that's how stacks and queues work. They're definitely useful. They have their uses, and I'm sure you'll use them if you have any sort of job type system that you need to build or a priority type system that you need to build. All right, let's head back over to our console and talk about sorting here. Close out of everything, minimize our stacks, queues, WinForms, and open up our console project once again. And let's take a look at how we can do a bubble sort. And we're going to bubble sort the very first array that we were working with here. So let's just get our numbers array back into our main method. And what we're going to eventually do here is call bubble sort from right here, so we can sort these numbers. We'll mix them all up, and then we'll sort them. So here's what I did. I just created a couple of very short and simple routines here. You can see there's not a lot of code here. It may look a little confusing, but there's really not a lot going on. And what we're doing is we're creating a bubble sort routine that accepts an array. So we're going to take the array, do a couple of loops in here with some logic in here that will allow us to compare every item to every item, move the small ones up the list, the large ones down the list until they're all in order. So the very first loop we have here, we're calling the pass. And really this is just going to be our outer loop. And we're going to loop through based on the length of the array. So you use the length property here to determine where you're at in the array. So this will give us a fixed number of loops based on however many items are in the array. So we've got 4 items in our array. So it's going to create, well, actually we've got 5 in our array here. So we're going to create a, oh, we need to take this out, don't we? Yeah, there we go. We should have 4 items, otherwise it would have blown up on us. So we've got 4 items in our array. So it's going to, the outer loop is going to loop 4 times. And then the second loop is going to loop 4 times. So what we're basically doing is the first pass through, it's going to compare, you know, the very first element to all the other elements. And then the second pass through is going to compare that to all the other elements. And then the third one's going to compare that to every element. So we're doing every, you know, item in the array compared to every item in the array. That's all these loops are doing by creating a nested loop. And what we're doing then is inside of our nested loop, we're comparing the current item in the array to the next item in the array. That's what the +1 is. And if it's greater than the next item in the array, then we're going to swap them out, because that means the next item is smaller than the current item. So we're going to swap them. And we're just going to keep swapping until everything's in order. And I'm going to give you a great way to kind of walk through this and visualize it by debugging, because you know, it'll make much more sense. So our swap routine just takes the array and takes the item that we want to swap with. And so we create a hold item here. Our hold item is going to equal whatever item we're passing in, because really what we want to do is we just want to swap this value with the next value. And that's all we're doing, is we're just switching them around. We're taking and storing inside of the current item is going to equal you know, the next item essentially, and then we're setting the next item equal to the current item. And again, the best way to see this is by showing here. So let me just copy this, and all we're going to do is pass in a bubble sort right here with our nums array, and let's just mix these numbers up a little bit. How about 43? We'll do a 75. How about a 3? And 118, right? So those are nice and mixed up, kind of. Let's see if we can get let's get a couple more in here just to mess things up a little bit here. All right, something like that. And one more. And we'll just call this one, how about 2? All right, something like that. So what we're going to do is let's just set a breakpoint down here so we can kind of walk through this stuff. Looks good. Everything looks good. All right, I'm going to hit run. And now the neat thing about doing this is you're going to be able to watch right here. Watch all these numbers flip around. See, here's our 5 elements inside of our array variable that got passed in. So I'm going to hit F11 on my keyboard. That's going to walk us through this line by line, statement by statement. See, so every statement by the semicolon, it's stopping on, because that's considered a statement. So far, it's going to compare 0 here. Our first run through, it's comparing 0 to 1. Is 0, 75, greater than 1, 43? It is. So guess what? We're going to swap them. So if we head down to our swap routine, that's all it's doing, flipping them around. See that? 43, 75 became 43, 43 became 75. So on our next pass through now, it's going to compare 75 to 3. 75 greater than 3? It sure is. So what's it going to do? It's going to swap it. Right? So it's going to do that for every item in the list then. And I'm just going to go ahead and hit F5, which will run through the whole thing once again. And what I can actually do here, if you want to see all this stuff before it actually outputs it to the window, I'll set a breakpoint here and hit F5. And now, check it out. All of our nums are in order because it compared them all. The big ones sunk to the bottom, small ones rose to the top, and the final result looks something like this: 2, 3, 32, 43, 75, and 118. So, not too bad, even though it kind of looks like it's never fun looking at loops within loops when you have arrays and all these indexes in here. It can look very, confusing. But thankfully, we have breakpoints, and you can set breakpoints. You can step through your code line by line, and use that watch window because you can see what every variable inside of your application looks like, the values within them, whether it's an array, a variable, an object, as you saw. I showed you the classes earlier. So use these surrounding tools because they're very informative, very useful, and they can really help you in understanding code and how it works. So the last thing I want to show you here is the quick sort, and the quick sort is easy to use because it's built in to .NET. So what I'm going to do is just minimize our number arrays here. Let's go into our string array list, and here's how easy it is to use. Ready for this? On an array list, we can just do a strings dot sort. There you go. That's all there is to it. And this is going to sort our string list array here alphabetically, so it's going to look like Yoda speaking. So if we just copy this, paste it up here, hit run. An array list dynamic is this? It's my Yoda impression. So that's all there is to it. Another thing I do want to mention though is the sort routine is not supported on a standard array. So if we do something like this, nums dot sort, nope, it's not there. You can reverse it, and this is all LINQ stuff, language integrated query stuff, which is a little outside of the realm of the basics, but I can tell you it's really cool stuff. So if you get into it, check out LINQ. We've got a few nuggets that talk about LINQ in another series. It's neat stuff, really neat stuff. But just to mention it, sorting isn't built in to standard arrays, but it is built into array lists. Another reason to get familiar and use array lists, because look how easy it is to sort, as opposed to creating your own sorting routines based on like the bubble sort algorithm and such. Alright, so in the CBT Nugget, we took a look at algorithms and data structures. We started off here with just a look at some of the common data structures out there, specifically arrays, array list, linked list, queues and stacks, some of the big ones that you'll be working with. All of these are just collections, a way for us to store a group of data. And then we took a look at some of the common algorithms out there, sorting algorithms, specifically here the bubble sort and the quick sort, and we saw how .NET supports them here, and we got some good demos on how to work with all of these objects. I hope this has been informative for you, and I thank you for viewing.